Everyone. My name is Esther Cho. I'll be walking you through end-to-end testing with Cypress. So before we get into Cypress, let's just talk about where end-to-end testing lands on the test pyramid. This is a concept created by Mike Cohn in his book, Succeeding with Agile. And it was designed to have developers kind of think about the different levels of testing so that when we're in the testing phase, we write tests with different granularity. And it visually represents that the more high level you get on the pyramid, the fewer tests you should have. So at the bottom, we have unit tests, which are super quick and easy to write. You could have a ton of these testing every single function you have in your app. And then end-to-end testing is all the way at the top, making them the slowest and most expensive tests you can run. End-to-end testing simulates a user's behavior on your application from start to finish to test functionality and performance. The biggest challenge with end-to-end testing, though, is flaky tests. And these are tests that produce different results, even though you have the same environment and the same inputs. So this can really slow down your CI/CD pipeline, because if you have unreliable tests, it could possibly mean that you have an unreliable product, and you can't launch with an unreliable product, right? So it's going to slow down your CI/CD pipeline. It can make testing super time consuming, because end-to-end tests can take upwards of 30 minutes to execute. And if you're having to go in and debug and look for an error that may not even exist and then rerun your test again for another 30 minutes, that time is really going to build up. Testing can also be super manual, right? So developers physically going into your application, manually inputting, manually typing in the inputs, and then executing your tests. This takes up a ton of developer and dedicated QA resources time, which can get super expensive in the long run. So in comes Cypress. This is an open source, user-friendly test automation tool for end-to-end testing. This was developed in 2015 by Brian Mann and Randall Kent to make testing a little bit easier, a little bit faster, and more reliable. And Cypress runs directly inside of the browser, and it's actually built on top of Mocha. So asynchronous testing is really simple and convenient with Cypress. Another option to Cypress is Selenium. Selenium, unfortunately, has a really steep learning curve because their setup is super complicated and challenging. There are 3 steps you need to set up Selenium. You need to download the JavaScript driver for each browser that you want to test for. And then those drivers are going to communicate through the network with the actual browser to execute your tests. You also have to set up a Selenium grid to distribute your tests to different environments, and then also download their IDE to actually record and replay your tests. Cypress, on the other hand, is the complete opposite. It runs directly on the browser. So it uses a DOM manipulation technique that will have your tests respond to application events in real time. And because it runs in the browser, it's quick and easy to set up. There are no additional downloads or dependencies that you need. Let's talk about some of Cypress's really cool features. So one of them is time travel. Cypress will capture snapshots of your tests at execution time. They offer great debuggability features with concise error messages that describe exactly why your test failed. And they have a core feature that they call retriability, so that developers can write faster tests with fewer runtime surprises. And lastly, they really combat flake resistance because their tests are designed to not run until your application reaches a desired state. Going into their time travel feature, so Cypress, again, will take DOM snapshots of your application while they execute test commands and assertions. And if we look to the example on the right here, you can see Cypress is running in the browser. On the left side, you have your test runner. This is going to show you all the commands and assertions that you've written for the test. If they pass, it'll show with green check marks and green highlighting. And on the right side, you see your application. So after your tests have run, you can actually go into your commands and assertions that you've wrote and then use the before and after toggle to look at the snapshots to see how your application responded to events. I know that we as developers all know the hell of debugging, reading an error message, trying to figure out why that error is happening, going into your code, staring at it for a few minutes, and then finally having that aha moment. Cypress will take all that guesswork out of your workflow and take you directly to that aha moment. So if we look at this example here, they are going to give you the error name, and this is either going to be a Cypress error, which corresponds to a command, or an assertion error, which corresponds to an assertion. And we'll get into the specifics of how those two differ in a little bit. Then they give you the error message, and this is the bread and butter of this error message, right? So they'll tell you where the command, or which command and assertion went wrong, which element failed and why it failed, and give you, documentation to anything if you need help troubleshooting. They also give you a direct link to your file in your IDE so that you can quickly go in and refactor. They give you a code frame, so a snippet of the code of where it failed. They give you access to your stack trace. And if you're more comfortable debugging inside of your browser with DevTools, you can choose to print this error to the console. Retriability is one of Cypress's core features, but before we get into it, I want to tell you the difference between commands and assertions. Commands are functions that you run before executing an assertion, and these can be either Cypress native commands, or you can create your own commands with your own functions. So if you have a function that you're constantly running, instead of having to write out that function every time, you can abstract it into a command and invoke it that way. Assertions are like assertions in any other testing framework. They compare your expected values to actual values pulled from the application so that you can confirm that something happened the way you expected it to. So going into what retriability is, we'll look at Cypress's get command. This command is built to be intuitive and to expect the state to potentially update. So if we look at this example code here up top, we're using the get command to query the DOM to look for elements with the class to-do list. And our assertion test is saying that we should find 2 of these elements in the DOM, right? But Cypress does not know if the application is done updating by the time the commands run, nor do they know if the application is done populating with data from the backend, right? So what it will do is it will query the DOM, look for the elements, and attempt the assertion. And if the assertion passes, then great, your command has run successfully. But if the assertion fails, then Cypress will continue to requery the DOM without being asked until it finds both elements, or until it reaches its timeout, which it will then throw an error. This really prevents developers from having to hard code in wait functions and timeouts in the test, making it a little bit cleaner, a little bit shorter. Flake resistance, how they combat this. Cypress runs synchronously with your application. So before they execute anything, they're going to wait for elements to become visible on the screen. They'll determine if an element is still animating and wait for it to stop. And they'll also check to see if an element is being covered up by another element. So if you have an element that's been previously tested, it passed all its tests, but now all of a sudden there's a big pop-up on your screen covering up that element. In real life, a user is not going to be able to interact with that element, right? So Cypress won't run the test until that error is resolved. They offer really great test management. You can enable a feature called test retries, and this, you can configure how many times you want to retry your tests, and Cypress will run the test that many times, check for consistent results, and flag flaky tests. They also offer Flaky test analytics that report overall flakiness level of your entire project and plot number of flaky tests over time. And these are meant to provide deeper context into your flaky tests and help you debug the root cause. So nothing is without its limitations, right? Cypress currently does not support Safari, but there are ways to kind of get around this with applications like Playwright or Applet tools. And the way you would do it is you navigate to your application through these third-party apps, but run your tests inside of Cypress. They are working on adding Safari support, and it is on their roadmap. So hopefully we can see that soon. Another big limitation is that multiple tabs are not supported. This is actually intentional by the Cypress team. They don't have any intention of making this a feature because they think that tests should be run a certain way. So for example, in your application, you are probably using an anchor tag to open new tabs in the browser, right? You can use Cypress to check to see that that tab has opened, but you should have a separate test file actually checking to see that all the components in that page has rendered successfully. So Cypress has a lot of really great features that make testing fast and simple. And I think the increase in productivity that you might see outweighs these limitations for sure. These are some of my resources. Thank you for listening.